So we actually had the article Full Steam Ahead, the benefits of integrating arts into STEM. The author's main point was that there's a growing need for STEM disciplines in America. And as a rule, the American education system is not meeting that need. However, in the instances that we do meet the need, we're also lacking in the creativity department. The author feels that the STEAM initiative, which would be science, technology, engineering, art, and mathematics, would meet the needs of both of those problems in the United States.
So we agree with this overarching idea of our article that we used, that art is needed in our STEM disciplines. By using STEAM, this can address the issues that the author poses, lack of interest in STEM and lack of creativity in STEM grads. However, he weakens his argument by focusing on financial success as his only metric to prove that STEAM is useful. Our project, our activity that we did as a class, is an example of how STEAM can be incorporated in the classroom.
So for our group Silk Batik painting, we decided to choose the sun as our macro image. But the sun's a really big object, right? So this is actually just a slice of that larger image. But the sun's a really cool object. As I'm sure you guys already know, it's just a ball of really dense gas and plasma. And that just means that there's a ton of little particles in there, protons and neutrons and electrons and all the little stuff that makes those up that are all kind of dancing around in there, and they're really hot, and that's basically just what a star is, right? But the cool stuff about that is that it's all held together by gravity, and gravity is strong enough for such a large object like this to cause particles, like protons in the case of fusion, which is what drives a star, to overcome their electrostatic repulsion, and that's just when they have 2 plus charges that don't want to go together because they're both the same charge. It overcomes that repulsion, and suddenly the strong force activates, and the strong force is what causes the gluons in your individual protons to communicate with each other and cause those protons to be super attached to each other. That's how you get a proton and a proton combining to eventually become something like helium. That happens again and again. We get bigger and bigger molecules, or atoms, excuse me. So in our painting, we showcase a few cool things about the sun, how the sun has what's called a corona, and that's an outer atmosphere of dense jets of plasma shooting out because those plasma are made of charged particles like electrons that like to follow magnetic field lines. So when we have arcs in our painting, some of those are these coronal ejections that are shooting out of the star and coming back to the surface. So on our painting, we also we showcase how fusion works by having 2 hydrogen atoms become a helium atom, and we also have a happy little accident of our carbon atom. And carbon, as I'm sure everyone knows, is what makes up a lot of the organic molecules in our bodies and that are necessary for life. And without stars to make stuff like that, we wouldn't have any of that stuff. So it's really important and cool. And down here we have the same motif of 2 hydrogen atoms combining to a helium atom. We also have a quark gluon plasma in here, which is kind of what you would see in the corona when it gets so hot. And there's a little bit of science that goes into how this painting was made as well. And we have several different kinds of paint. The paint has a binding agent in it already, but that binding agent doesn't have enough energy at room temperature to bind easily with the silk, since silk is kind of a dense protein. So by heat setting our painting, we give that binding agent enough energy to actively bind with the silk between the paint so that the paint sticks to our silk batik. So maybe we'll learn a little bit more about the art stuff here in just a second.
So what we did for our project to relate the science and the art together into one lesson was the batik silk painting. And first of all, I'm going to talk about the texture, which was probably one of our biggest challenges, seeing that we did a micro image of the sun. So what we did was first we did a lot of color matching and blending into the main part of the painting. And then we used salt to kind of give that bubbly texture for the sun. And then we used the alcohol and vinegar to kind of blot and blend the colors into each other better. Now I'm going to go into the colors that we used. So we used primary colors, which are red, blue, and yellow. We used those paints, those color paints, to make the secondary colors, which are purple, green, and orange, which you see primarily in this painting. We didn't use a whole lot of green, but we did use a lot of orange, red, and purple. These colors all relate to a value scale, and they all relate to the gray scale when translated into that gray scale. So basically what we did is we related these colors to the color spectrum, and so the sun is hot and cold. There's cold and hot spots on the sun, and so we use these colors on the grayscale color spectrum to show the different heat intensities within the sun on our micro image that we did for our batik silk painting.
So I got a lot out of this project, I think, because as an educator and a human being, I really value communication. I mean, that's how we can share our knowledge. And art gives us ways to communicate that we maybe wouldn't have had otherwise. So for me, being able to work with Staley and the rest of the art students was really cool to be able to kind of focus on how we can communicate in these different sorts of ways.
On the art side of things, it was really beneficial to work with my science group because I never would have really known the exact science behind how paint sticks to the fabric or the canvas or silk especially. So that was very beneficial to me, and I learned more science behind the color mixing aspect. Instead of just, you know, red and blue make purple, I learned how it makes purple.
So it was really cool, and STEAM is maybe some good stuff, eh?